So, hello everyone. We have gathered here to learn about singly linked list. So, in the last tutorial, I have tell you about what is a linked list, what the type of different types of linked list. So now we will today discuss about the coding. So let's work singly linked list. For this, let's include the starting packages. Hash include stdio.h include stdio.h hash include conio.h hash include, let us also include the standard libraries, and that's enough. Now we know that in a linked list, obviously we will need a structure. So let us make a structure with name node. For every node, the data part had to be stored in variable I of integer type, and the pointer of the structure be next. You can give your own name, doesn't matter, and we always put a semicolon after the structure. It's the basic syntax. So let's start. Now before starting, I can make a struct node start, the starting node. I have initialized it outside the function because I will need it in every function. So let's start. Now let us create a function. Now we have different type of tasks to do in this, that we can add a node at beginning, and we can add a node at last, or we can add a node at specific position, and many more. So let us start one by one. So for the first, let us start void add at beginning. In this function we will add a node at beginning. Okay, struct node start e. Okay, let this be the let t be the node which we want to add. So we will allocate some memory to it. Struct node start, struct node start malloc size of struct node. Okay, yeah. Now let us check if memory is allocated or not. If t equal to null, then if yes, we will print that memory. If memory is not allocated, then we will give out the message. So that means we have to do our whole program in the else part. For the else part, let us check again if start equal to null. That means there is no node in the linked list. So the first linked list will be the linked list which we have created. That's all. Before this, here or here, doesn't matter, we can get the value of the node which we want to insert. Enter the value of the node. We can directly save the value to the address of t, that is like this. And for the initial purpose, we can say t.next equal to null for the initial time. Later on we can change it. So we have got the value. Now we have to we have got the value and we have inserted it into the data part of the node. Now we have to join the link. So now if start equal to null, then start equal to t, and else t of next equal to start, and start equal to t. By this we can add the node at the starting part. So else is closed and the upper else is closed, and I hope uh, one more and then function. Okay, so by this program we can add this. So now let us make one more function to void added last. Now for this we need two node, one node P for the node which we are going to add, and one P, the node by which we can traverse the linked list up to the end, because we want to add the list at end. Okay, so let us now first allocate the memory to P. Struct node star malloc size of struct node. Okay, now again we will check if P equal to null. If yes, then again we will print the message, same message, get memory is not allocated. Else, if memory is allocated, then we have to do a work. We first of all get the value, printf, and the value of the node, scanf %d admin t of I. Directly send the value t of I. Again for the initial part we can initialize the link part equal to null, it doesn't matter. So now we have to add the node at the end. For the end we have to traverse the link. For traversing we used P. So P equal to start means P equal to start, and P the next not equal to null. Null, that means, and P equal to P of next semicolon. Now the initialization part is P equal to start. That means from the starting of the linked list, and each time we are checking that it is the next part is not null, and each the updation part is P equal to P of next. That is we are going to the next node. Now this semicolon is used for this loop will execute in this statement itself. This the program will come out of this loop when once the terminating condition is fulfilled. So P equal to start. So now after this condition we will get to the end of the linked list. So at the end we have to do nothing but P of next equal to P. That's all. A node will be added at the end. Else part closed. We can also give a condition here that if start equal to null. If yes, that means there is only one node, start equal to T. Else. So for else we have to do this part. For else we will do this, and we will close the up else and then the program. So we have created a function void add last to add a node at the last, and void add beginning to add a node at diff. Now we can take a one more case to add, like now if someone said that I want to add a node at a specific position, or someone says that I want to add a node before any other node, so we can also do that. Just we have to, so let us practice one more function for this. Void bit before, let's say add bit before, means in this function we will gonna add a node before a node. The value of the node will be given, and the value of the node which we want to add will also be given. So we have to just search for that number and add a node just before it. That's the simple work we have to do. So T will be the node which we want to add, and P will be the node which is used for the traversal in the linked list. both initialize as null, otherwise we will have some issue with the garbage collection. Then let us first allocate the memory equal to struct node star malloc size of struct node. We have allocated the memory to t. Now let us check if t equal to null. If yes, then we get to know that memory is not allocated. Else what we have to do? In else, first of all we will get the value. We have to ask for the value. Temporary value of the node. Scanf %d address of p of I. Directly send it to there. And again, for the initial purpose, we can declare it as null. Now let us check if start equal to null. Start equal to if there, it means there is only one node present. There is no node present in the linked list, so the node which we want to add will be the node only. So we have to given start equal to t. Let us close this and we'll go for the else part. For the else part, we have to know the number before which we want to add. So enter, let us say search number. Okay, search number. So we have to make a variable. We have to make a variable for it. So let us make a variable. Let the name be in sr number equal to 0. Again, keeping in mind the garbage collection. Scanf %d and of sr number. Now we have to add a node t before this node which have sr number, search number. Okay, so we will make a loop for p equal to start from beginning. Now we will have two termination condition. Either we found the search number or we go to the end of the list. So if we found that number, what was the condition? If p of next of I equal to the sr number and p not equal to null. These are the two conditions, and each time we have to update the value of p by p equal to p of next. It means each time going forward for the new node. Now we again put the semicolon so that we will complete this for loop. Now we will come out this for loop at the two condition only. Either we complete our list or we found the number. Now let us take the base case. If we have reached the end of the list, if p equal to null, that means we have reached the end of the loop and we had not found the number. So we can write search number could not be found in the list. Simple. Okay. Else we have found the else part, we have found the number, so we could directly link that the link part of the temporary link part of the node t will be equal to the link part of the p, and p of next equal to t. Now this is the coding of this. So else part closed. above else part closed, and one more else part. Let us see again, and one more for the function. On that sound. Now these are the different part of the insertion things, how we can insert. There are many more of them. You could study them. Now we have covered the basic things. Now let us go. Let us create one more function, void print. For printing, we will make a node again, node star p. It will be used for the traversal. For p equal to start, p not equal to null, equal to p of next. Each time we'll print the, we can give here some spacings, printf what isn't needed, no problem for that. Printf person 5D means just creating some spaces between the each numbers. Now we'll give printf p of I. By this we can print it. That's all for the print. Now let us come to the main part, main program, main function it is. So let us make scr, create a screen each time, and you can call all the function at beginning, at last, according to your choice. Add mid before, according to your choice. I'm not doing this main function as the programmer wants an output, so he can accordingly set this function in the main function. So means you can make the appropriate calls. So I've created 3 functions: at beginning, at last, and at before. So then we can execute it, and then the programmer can execute it by itself. So in this tutorial we have completed the insertion part of the linked list, and in the next video we will learn about the coding of the deletion part. Thank you.